Hey everyone! Today I'll be going over how to use the includes method in Rails to reduce SQL queries and hopefully improve performance. I'll also be going over several situations where includes doesn't work and what you can do about it. I'll start by introducing an example project that will help illustrate these situations. The example project is available on GitHub and is linked in the description. In this example, I have a model called author. Authors have many articles, and articles have many comments. Authors also belong to a city. I have generated some example data. There are 3 authors. Each author has 10 articles, and each article has 10 comments, for a total of 300 comments. The authors also each belong to one of 2 different cities. Let's generate some SQL queries. We'll start with a simple table with just the authors and their articles. We get all of the authors in the database, and then for each author, we loop over their articles and display them in the table. To view the SQL that gets generated by this code, we'll be using a gem called Rack Mini Profiler. Each time we load the page, it adds a tab to the upper left corner that will show us how long the page took to build on the server and what SQL queries were executed. If this is the first time you've loaded a page since you started the server, you'll get some extra queries as the database adapter asks the database about its tables, so it can add the corresponding attributes to your models. This is why active record model objects automatically get attributes for each of their corresponding database columns. For example, my comment model gets a full text attribute at runtime even though I never define it. It comes from these initial queries about the database tables. If we load the page again, we'll see those queries go away. For this page, we get 5 SQL queries. Let's see what they are. The first query, select1, is generated by the database adapter and is basically a ping to check if the database is responding. The second query corresponds to our call to author.all in the controller. The remaining 3 queries ask for all the articles that belong to a certain author. These come from inside the author loop, where we ask each of the 3 authors for their articles. The profiler doesn't show the actual IDs passed into the query, but you can get this information from the server log if needed. Executing 3 SQL queries is not a big deal, but for every author we add to the database, we'll get another query. This is called an n+1 query. With enough authors, the latency of going back and forth to the database will slow the page down. Ideally, we'd like to ask the database for the 3 authors' articles in a single query. The includes method allows us to do just that. Back in the controller, we add a call to the includes method specifying we want to include the articles along with the authors. Now when we load the same view, we only get 3 SQL queries. The ping query, the query for all the authors, and a query to get all the articles where the author ID is one of these 3 IDs. Behind the scenes, Active Record takes all the articles returned by this query, groups them by author ID, and adds them to the corresponding author object. This is accomplished using something called the association cache. Every active record model object has a hash called association cache that stores the data for associated records. For example, even without includes, if you ask for an author's articles twice, only the first call will result in a SQL query. For the second call, the article data will be read from the association cache. The includes method allows you to preload multiple objects' association caches from a single query. If we don't use includes and check the association cache, we can see that it's empty, whereas if we use includes, the association cache of each author is already populated with article data, so when we ask for the author's articles later, we won't have to execute any SQL queries. That is the core functionality of the includes method. Now let's look at some more complicated examples. At the beginning I mentioned that articles also have many comments, and authors belong to a city. Let's look at a table that displays all of this information. We have 3 nested loops, resulting in 1 row per comment. In addition to the author and the article name, we also include the city name and the comment body. We're currently not using includes, so let's look at the SQL queries. There's a lot going on here, so I'll summarize. We have the ping query and the query for all the authors. There are 3 queries for all the articles associated with each of the 3 authors. There are 2 queries for a city with a certain ID, and there are 30 queries for all the comments associated with each of the 30 articles, for a total of 37 queries. So after we get all the authors, each time we ask an author for its articles, we get a SQL query, and each time we ask an article for its comments, we get a SQL query. Interestingly, we only get 2 queries asking for a city, even though we ask all 3 authors for their city. This is because 2 of the authors belong to the same city, so when we ask the second author for their city, it generates the SQL query to ask for their city, but because the query is identical to a previous query, the Rails Query Cache returns the cached response without hitting the database. The other queries cannot be cached in this way because they all use different IDs. It's worth noting that even though the SQL cache is much faster than actually hitting the database, it's still considerably slower than not generating the query at all. Cached SQL queries don't show up in the profiler, but they may still be causing a performance problem. Looking at the server log, you can see cached queries, but if you want to see those queries in the profiler with a stack trace, you can disable the cache by wrapping the relevant code in a call to activerecordbase.uncached. When I use rack mini profiler to investigate a page, I almost always disable the cache with this method to get a clearer picture of what's going on. I recently came across a page in a professional Rails app that was being slowed down by numerous cached queries. At first it seemed like there was hardly any SQL being executed, but looking at the server log, I saw tons of cached queries, and disabling the cache, I found 512 queries were being generated. Because most of the queries were identical, the cache was handling most of them, but there was still a performance cost. With the SQL cache disabled, the page took around 2,250 milliseconds to render. With the SQL cache enabled, the page took around 1,400 milliseconds to render. And using includes to eliminate most of the queries altogether, the page only took 150 milliseconds to render. This is a rather extreme example, but if you are profiling a page and it's still slow despite very few SQL queries showing up in the profiler, cached queries may be the problem. Check the server log and try disabling the cache to get a better picture of what's going on. Back in our main example, we've got 37 uncached queries to deal with. Let's try to eliminate most of them. We need to load all of the relevant articles, comments, and cities, organize them, and add them to the various models association caches. The includes method allows us to do just that. The syntax for including multiple levels of a hierarchy takes some getting used to, but it's pretty straightforward. We want to include the author's city and their articles, and we want to include the article's comments. Includes calls can get very complicated and still work. Here's an example from an app I'm working on. Let's see what kind of queries we get with this include statement. We're able to load all of this data using only 5 queries. There's a query for each type of record, passing in a list of IDs. Each call is based on the data from the previous call. So after we get all of the articles, we take those articles' IDs and query the comment table for any comments whose article ID is in this list. Rails takes all of that data and ensures it gets to the right places, so when the various associations are requested, they're already cached. Includes is extremely powerful and can handle surprisingly complex multi-level associations, but there are a few situations where it will not work as expected. Let's look at several of these situations and see how they can be remedied. The simplest situation where includes doesn't help is when you only have one record. If we want to include the city and articles for a single author, it will let us call includes, but it still needs to make one SQL query to get the city, and another to get the articles, so it doesn't actually reduce the number of database queries. As silly as this sounds, I've done this several times. The next situation is where after all the records have been preloaded, another part of the code requests an additional SQL operation on the same data. In this example, we preload all of the data in the controller, but in the view, we request a scope that limits the comments list to just the comments with more than 5 likes. The comments have already been cached, but this scope adds a where clause, and because Rails doesn't know how to apply the where clause to the comments, it has to execute a new SQL query. We end up with 35 SQL queries, The city and article queries are successfully combined, but we still get 30 queries from requesting the scoped comments. We actually get one extra query where it preloads all the comments, but those preloaded comments never get used. If you try to include an association and you actually get more queries, there's likely some additional SQL getting used somewhere that means it can't use the preloaded records. It's not possible to preload a scope using the includes method, but you can do one of two things. You can remove the scope and instead perform the filtering in Ruby. Here I'm using the select method and checking the like count in Ruby code. I'm back down to 5 SQL queries because I'm able to use the preloaded records. If you need to filter a giant list of records, doing it in SQL may be faster, but for many situations, Ruby will be faster if it means reducing the number of SQL queries. The other option is to use a has-many association with a where clause. Instead of defining a scope in the comment model, we add a new has-many association to the article model. It's called comments with at least 5 likes, and it has a where clause to filter the comments. It's possible to preload this association using the includes method. Again, we're down to 5 SQL queries. In addition to scopes, there are several other Rails features that can cause includes caching to not get used. There are several query methods that require new SQL queries to be run. For example, the order method adds an order by query that will have to be executed. Replacing it with the Ruby sort by method will allow you to use the associations cached by the includes call. Again, for a very large number of records, sorting them in Ruby may be slower than using the database, but it's worth a shot. If you're familiar with SQL, you may be wondering if there's a way to use joins to pull in multiple tables in one query instead of multiple simple queries. There is, though often the simpler queries will be faster. In most cases, calling includes is equivalent to calling the preload method. Preload behaves, as I've already described, to fetch and cache records, but under some circumstances, includes will instead call the eager load method. Eager load uses left outer joins to pull in multiple tables in a single query. Using eager load makes it possible to execute SQL commands that depend on the tables being joined. But if you are primarily using includes for performance reasons, the default preload behavior is probably what you want. There is also the joins method, but the joins method uses an inner join, so it may not behave as you expect. If, for example, you joined the authors on city, if any of the authors don't have a city, they won't show up at all in the returned list. That covers most of the relevant background behind the includes method. With a deeper understanding of how includes works, you should be able to effectively troubleshoot situations where it doesn't work as expected. I'll close with some additional information about the rack mini profiler. The profiler shows a percent in SQL number. This means how much time it took for the SQL to execute on the database side. It doesn't include time spent communicating back and forth with the database. If you have a ton of simple database calls, most of the time will be spent communicating. So the percent in SQL number may be really low, even though SQL is the cause of the performance problem. The percent in SQL number will be high in cases where you are executing complicated queries on large amounts of data. In those cases, most of the time will actually be spent on the database side performing the query. In those situations, you will have to look into writing more optimized SQL, adding indices and other traditional database optimization methods. In some cases, your performance problem won't have anything to do with the database. By default, the rack mini profiler only shows very basic non-SQL information. But if you click on More, you can see a list of additional commands to get more information from the profiler. If you install the StackProf gem, you can use the flame graph option to see a detailed breakdown of all the code that gets executed to render the page. I find the left heavy view option is the most useful. The flame graph has helped me catch several performance issues that weren't caused by the database. For example, reading complicated objects from the Rails cache can be surprisingly expensive if you do it a lot. That covers most of the concepts I use when trying to improve performance in Rails. If you found this video informative, consider giving it a like. And if you have any additional Rails performance tips, let me know in the comments. Thanks for watching.